Okay, hopefully you have printed out the fill-in-the-blank notes that were attached to the week 10 announcements inside D2L. I mentioned to you last Wednesday that they were there and that we would be using them today to kind of help us go through this discussion. Last week we talked about the central limit theorem, but remember there are no questions on the test. There are no questions, no homework, and no practice problems for the central limit theorem. There are practice problems and homework problems for the confidence intervals for both Z as in zebra and T as in tiger. Okay, so if you've had an opportunity to look at those, do you have questions related to that before we pick up today's discussion? Okay, today we're going to be looking at the hypothesis testing process. And then at the end, hopefully we have an opportunity to look at a couple of examples. Hypothesis testing is really going to be our topic or our focus from now till the end of the term. We will ultimately look at 5 different types of tests. The process used for that hypothesis testing is the same, regardless of which test or which distribution we're using. Okay, so that's what I want to help outline for you first of all today. And you can think about hypothesis testing in a couple of different ways. You can think about it like a court case, okay, where you're trying to decide whether a particular person, whether the defendant is guilty or not guilty. You can also think about it sort of like a science experiment. Probably all of you at some point hopefully have experienced a lab within a science, whether it be chemistry or biology. And oftentimes what you want to do before that is you state a hypothesis. You provide an educated guess about what you think is going to happen during that experiment. Well, it's a similar idea within statistics. Within statistics, we often pose a research question. For example, one of the questions we've looked at previously was, what is the average age of a GHC student in fall 2020? Okay, so we pose that question and then we begin collecting the data. But guys, oftentimes when you pose a question like that, you may not verbalize it, you may not write it down, but you probably have, at least in your mind, a possible answer to that question. You know, I could say, I think, or I believe that the average age of a GHC student in fall 2020 is 23. And that's kind of my prediction or my educated guess. So that's like having a hypothesis. And then we go through the process of, in a sense, performing the experiment to decide or determine if our educated guess is valid or invalid. Is it good or bad? Okay, so a hypothesis, if you haven't already guessed, a hypothesis is our educated guess or our proposed answer to a research question. Okay, a hypothesis, similar to what you would see in a science class, is an educated guess or a proposed answer to our research question. And there's a very lockstep, if you will, a very rigid process that we go through to determine whether or not our proposed answer is valid or invalid, whether it's good or bad. And so I want to kind of walk through and discuss that process, and then we're actually going to do it. Okay, so step one in the process is you state the two opposing hypotheses. You state the two opposing hypotheses. The first hypothesis is called the null hypothesis. The symbol that you'll often see is we use the capital H for hypothesis, and it has a subscript of 0. You may not realize it, but the word null is an old-timey word for nothing or none, 0. So that's why we use a subscript of 0. The null hypothesis is a claim about a population parameter that is assumed to be true throughout the entire process. It must always contain equal in some form. Okay, a couple of things there in that statement, okay? Our hypothesis is always related to a population parameter. Remember, the population is our big picture. So our hypothesis is related to a measurement associated with the population. Now, we could have a claim or a hypothesis about the mean, the standard deviation, the variance. We could do any of our population parameters. Our primary focus is going to be on the mean. Okay, our primary focus is going to be on the mean. The other statement here that's important to note is that it says the null hypothesis always contains equal in some form. So the three options you have here are it could contain equal, it could contain less than or equal, or it could have greater than or equal. Those are your three options as far as the symbol within the null hypothesis. The other thing that I want to point out to you there is it says that the null hypothesis is assumed to be true. Again, if you think about it in terms of a court case, a person is presumed innocent or assumed innocent until proven guilty. So our null hypothesis is assumed to be true until we prove otherwise. Okay? The second hypothesis is called the alternative. It's called the alternative hypothesis. The symbol is the capital H, again for hypothesis, and we use a subscript of A for alternative. And again, it's also this claim about the same population parameter that is the exact opposite of the null. It will never contain equal in any form, and it also determines what we call the type of test. Now, determining the type of test is more important if you were doing these calculations manually by hand, or if you're using your calculator or some of the free websites. Minitab, we do indicate which one we have, not necessarily using the same terminology that I'm about to introduce to you. But there are two different types of tests that can occur. You can have what's called a one-tail test if the alternative hypothesis contains either less than or greater than. And the reason it's called a one-tailed test is because if you say that the age is less than 23, okay, you only got one option. You got one option that it's just less than. But on the other hand, I could say the average age is greater than 23. And there again, I just have one option. I just have the option that it's greater than 23. Okay, so you have one option. The other one is called a two-tailed test. A two-tailed test occurs if the alternative hypothesis contains not equal. Okay, because the idea of being not equal allows for the possibility that you have the option it's less, or you have the option that it's more. So you have two choices or two options. So you have a two-tailed test. Now, one of the hypotheses will be stated in the scenario. For our purposes, one of those will be stated in the scenario. Now, if you were the actual researcher, you would have to determine what your null or your alternative hypothesis was going to be. Okay, but for us, the problem is presented in a paragraph of 3 to 4 sentences, and somewhere in those 3 to 4 sentences, it's going to give you one of the hypotheses. You have to figure out which one do you have. Which one is given? Are you given the null hypothesis, or are you given the alternative hypothesis? Guys, it's all in the phrasing. It's all in the phrasing. And on the PowerPoint related to this topic in D2L for hypothesis testing, there is a slide that has a list of words that can mean equal, or words that can mean less than, or words that can mean greater than, because you're going to have to read carefully to determine which one of those you are given. Once you have determined the one you're given, you can figure out the other one because they're exact opposites of each other. So the first step is we state our hypotheses. Then the second step is you would collect the sample data and calculate the descriptive statistics. If you were truly doing real world research, you've posed your research question, then you're going to go out and collect your data and have to do all of the steps we were doing before, creating our frequency distribution, creating our histograms and our stem and leaf plots, finding those descriptive statistics, mean, median, mode, range. You'd have to do all that, okay? Because of the limitations of time and being in the classroom, we can't do that. So it says, or identify the given information. All of the information that you need to work the problem, to conduct the hypothesis test, will be given to you in the scenario. Okay, identify the information given in the scenario. Now, you may then say, well, Ms. Ralston, what information do I need? Well, the information that's needed depends on which distribution or which test is being conducted. The information that you're given actually is going to determine which distribution and ultimately which test you need to conduct. The information that you're given in the scenario is going to determine which distribution you should use, which ultimately leads you to the test you should conduct. And it's different for each test. Okay, and we'll talk about that. Step 3 is we're going to determine which distribution or which test to conduct based on the information that we got in the problem. The first one that we're going to talk about in Module 3, and I'm going to make a note here that this is in Module 3, M3, is a z-test. Okay, the z-test is used if you have quantitative data. Remember, quantitative data means you're going to have numbers. Okay. If n, which is your sample size, is greater than or equal to 30, so that you have a large sample, the most important piece here, the z-test is used when the population standard deviation is known or given to you in the problem. And that should sound familiar, because if you go back to last Wednesday when we were talking about confidence intervals, we said we would use Z interval whenever we knew the population standard deviation. It's the same guideline. If you know the population standard deviation, first of all, you're going to use it, and you're going to use it to conduct a Z test. And that is related to the normal distribution. Remember, that's our nice bell-shaped symmetric distribution with the mean in the middle. Okay, so we're going to talk about z-test a little bit later today. We'll look at some examples. But a z-test is used if you have quantitative data, a large sample, and you know the population standard deviation. Okay, the second one that we're going to talk about, which is also in Module 3. Oh, wait, let me tell you this first. I always forget this part. Let's talk about what information you need or are given in relationship to the z-test. In the scenario, you will be given the population mean, which is represented by mu, and that is the value that is in the hypothesis. You'll be given the population standard deviation, which is sigma. That will be given in the problem, and it will be clearly identified as the population standard deviation. You'll have the sample mean, which is X bar. That's going to be given in the problem. You'll have the sample size, which is N. That's given in the problem. And lastly, you have the significance level, which is represented by the Greek letter alpha. Now, remember, we talked about significance level last week. Remember, there's a connection between confidence level and significance level. Confidence level is the probability of success, or the probability that you're right. The significance level is the probability that you're wrong, or that it's the probability of failure. And remember, the two of those added together have to total 100%. Okay, the two added together have to add to 100%. The challenge is normally confidence levels are written as percentages. Significance levels are written as decimals. So you have to be able to convert between the two. But all the pieces that you need to conduct the test are given to you in the problem. You just have to identify which number is which. That requires that you read carefully. The second one that we're going to talk about in Module 3, so this one is also in Module 3, is the t-test. Okay, t-test, again, deals with quantitative data. So you'll have numbers. Your sample size is less than 30, which means we have what is termed a small sample. For the t-test, the population standard deviation is not known or given. Typically, you will have the sample standard deviation. The t-test relates back to the student's t-distribution that we talked about and I introduced you to last week when we were talking about the t-interval. The statistics that you need, again, should be given to you in your scenario. And those statistics are, again, the population mean, which will be the value that is in your hypothesis. You'll have the sample standard deviation, which is S. You'll have the sample mean, which is X bar. The sample size, which is N. And you'll have the significance level, or sometimes they'll say level of significance. It's the same thing, which is alpha. Now, the other three that are listed here will be our focus in Module 4. But I want to kind of give you just a little bit of a heads up. Chi-square goodness of fit is one of the few statistical analyses that you can do with qualitative data. Okay, so we'll revisit qualitative data and talk about chi-square goodness of fit. Analysis of variance, or ANOVA as it's abbreviated, is quantitative data, so it's numbers sorted by a qualitative variable. An example of ANOVA might be that we want to look at the wait times in the drive-through of the various McDonald's locations in Cartersville. Okay, so I'm taking the wait times, which are numbers, and I'm sorting them by location, which is qualitative. So it is quantitative data sorted by qualitative. And then correlation is what we call bivariate quantitative. Bivariate, bi means two. So we'll have two variables that are both numbers, they're quantitative, and we're looking at the relationship. Okay, we're going to be using Minitab, not the free website. We went to the free website last spring when we had to go to remote learning. Okay, so after you've proposed your hypothesis, you've identified your information, you've decided which test you're going to do, then you're going to do the test. So you're going to calculate and record, you're going to write it down, the test statistic based on your data and the corresponding p-value. Okay, the test statistic, again, if you think about it like a court case, is your evidence. Okay, the test statistic is your evidence. You've taken your data and you've calculated this measurement. Okay, so they've collected the evidence and they're going to present it to you. That's the test statistic. Let's talk for a minute about the p-value. P-value is an abbreviation for the phrase probability value. Okay, so the p-value represents a probability. Now, one thing I want you to remember, because a lot of you seem to forget this, is that probabilities are between 0 and 1. Remember, probabilities are always between 0 and 1, meaning I'm not going to get a p-value that's negative, nor am I going to get a p-value that is greater than 1. Okay, that's a no-no. That breaks the rules of probability. What that probability value represents, and this is where it gets, for students, sometimes gets a little bit hinky, or you're going, what? Okay, here's what it means. It is the probability of getting the same test statistic over and over and over if the null hypothesis is true. Meaning, results from another random sample will be as extreme or more extreme than the results of the given sample. You know, typically we try to perform the experiment more than one time to see if we get consistent results. And that's kind of the idea here. Are we getting consistent results? What's the chance that I'm going to continue to get a similar test statistic for different samples? Okay, again, that's kind of something that goes on behind the scenes. Minitab or other technologies will calculate the test statistic and its p-value for you, because every test statistic has its own unique p-value. Okay, so Minitab, calculator, other softwares are going to calculate that for you. You have to interpret that information. Okay, so you've seen the evidence. Your test statistic is your evidence. You've seen the evidence. So once the jury has seen the evidence, they go out to deliberate. So that's really where we are at step 5, is the deliberations, where we're trying to make a decision about whether the defendant is guilty or not guilty. Now, that's not the terminology we use in statistics. Okay, so in step 5, is where we're going to make our decision. And we're going to think about, again, it's the idea of trying to decide, are they guilty or not guilty? Now, here's the phrasing. We make a decision to reject the null hypothesis or fail to reject the null hypothesis. Now, guys, those phrases are important, okay? And I want to talk about that for just a minute. The idea that we reject the null hypothesis, and if you're thinking about it in terms of your court case, that would be saying that the person is guilty because we're going to reject the belief that they're innocent. And if you reject innocence, that means they're guilty based on the evidence that we have. Fail to reject the null hypothesis would be not guilty. But guys, notice those words. Even in a court case, we talk about a person being guilty or not guilty. We don't say guilty or innocent. They're simply not guilty based on the evidence presented, or they're guilty based on the evidence presented. There is that possibility that they actually performed what, they did the crime, but the evidence doesn't allow you to know that. They don't have enough evidence to prove it. Guys, never, ever use the word accept the null hypothesis. That will crawl Miss Ralston's skin faster than anything. That is statistically incorrect. You either reject the null or you fail to reject the null. Also notice that it's in terms of the null. Because remember, way back up in step 1, we've assumed that the null is true. Just like we assumed the defendant was innocent until our evidence proved otherwise. But the evidence doesn't completely exonerate them. Okay, there's still that lingering bit of doubt. If we had different evidence, would we come to a different conclusion? The way we decide whether to reject or fail to reject is we compare the p-value to the level of significance. Now remember, the level of significance is given to you in the problem. The p-value will be calculated by Minitab, and then we're going to compare the two. Using the following guidelines. Guys, these guidelines are set in stone. They do not, will not ever change, regardless of what kind of hypothesis test you're doing. Whether you're doing Z or T or chi-square or ANOVA or correlation. These rules are set in stone. They are what they are all the time, every time. Okay, so it says if the p-value is less than or equal to the level of significance, then you reject the null. Now in symbols, we would usually write P is less than or equal to alpha. We reject the null. If the p-value is less than or equal to the level of significance, which is alpha, then you reject the null hypothesis. On the flip side of that, if the p-value is greater than the level of significance, then you fail to reject the null hypothesis. So if P is greater than alpha, you fail to reject the null. The last step is once you're all done, you know, even after the jury deliberates and has made their decision, they have to come back and tell the judge in the court what they decided. So the last step is you write a final conclusion in terms of the null hypothesis, including the level of significance. Everything is predicated or tied back to that null hypothesis. Okay, so there are the 6 steps. We're going to go through hopefully 2 examples, maybe 3, depending on our time. Okay, and walk through those steps together. Now, our focus is going to be either on the Z test or the T test. Okay, now the difference, remember, is do you have the population standard deviation or not? Okay, do you have the population standard deviation or not? If you do, it's Z. If you don't, it's T. You really need to read the entire question from beginning to end. Okay, you need to read the entire question from beginning to end before you ever do anything. Okay, so it says, a manufacturer of chocolate chips would like to know if its bag filling machine works correctly at the 438 gram setting. It is believed that the machine is underfilling the bags, thus cheating customers. 37 bags were sampled and found to have a mean of 435 grams. Assume the population standard deviation of 14. Using a 0.05 significance level, determine if the bag filling machine is under filling the bags. Okay, so I'm going to kind of write this out as we go. So if we're thinking about step 1, we state the hypotheses. Now guys, in the homework and in the practice problems, these are set up as matching, not matching, as a like multiple choice or fill in the blank. Okay, so I would suggest that you work through the problem, walk through these steps like I'm about to do, and then go back to the questions on the homework and answer the questions. Okay, so the first step is to state the hypotheses. And normally you'll see it written, if you're seeing it as a write-up, normally you have H sub O on the top, you have H sub A on the bottom. Okay, that's how they're set up. One of those is going to be given to you in the problem. And typically, when you're trying to identify your hypothesis, you want to look for words like conclude, believe, think. This one also uses the word determine. And most times, again, remember these problems are kind of contrived. They're set up, written by Ms. Ralston. And so most times you'll find that hypothesis near the end. It's actually in this particular paragraph twice, because it says, it is believed that the machine is underfilling the bags. And then in the last sentence, it defines underfilling means it's putting less than 438 grams. So I hope that that phrase, less than, makes you think of the symbol mathematically of less than. So would that symbol go in my null or my alternative? You have to ask yourself, does it have equal in it? No, if it doesn't have equal, it goes in the alternative. So this statement that it's underfilling the bags or is less than 438 grams is my alternative. And here's how I'm going to write it. You have to put in your population parameter. The hypothesis must contain the population parameter. So you're going to put mean is less than 438 grams. That's what the statement says. I just translated it from words to symbols. That's the one that's in the problem. The null is not in the problem, but I should be able to figure out what it should be because I know it's the exact opposite of less than. So what is the exact opposite of less than? Greater than or equal to. Remember, you got to put the equal in there. And it's still going to be the mean is greater than or equal to the 438 grams. The population parameter value of 438 doesn't change. Okay, so there are our hypotheses. The alternative was given to us in the problem, and then we figured out what the null should be. Step 2, just to kind of shorten it, is to identify the players. Identify the information that you've been given in the problem. And I told you earlier, in both cases, you know the population mean, you know the sample size, or excuse me, you know the sample mean, you know the sample size, and you know the significance level. The piece that varies from question to question is whether or not you have the population standard deviation or the sample standard deviation. So you got to pay attention because all the pieces are given in this problem. If I go back, I can scan through it and find those, okay? Let's see, third sentence, 37 bags. So that's my N, that's my sample size. I checked 37 bags were sampled and found to have a mean of 435 grams. So my mean is 435, my sample mean. Then it says, assume the population standard deviation of 14. So in this case, it's giving me the population standard deviation, and it's 14. Using a 0.05 significance level. The population mean comes from your hypothesis. Okay, so it's 438. This one comes from your hypothesis. So all the information that I need has been given to me in the problem. I've got the population mean, the sample size. In this case, I have the population standard deviation, and I have the significance level. Now, two little side notes here. If my significance level is 0.05, which is 5%, what would be the confidence level? 95, thank you. Okay? Now, the third step is to decide which test to do. And right now, you're only choosing between either a Z or a T. Okay? Right now, you're only going to choose between a Z or a T. We're going to do a Z because we know the population standard deviation. The problem clearly, and I have it highlighted in green. Yes, Trey.
Now, for the Z and
T.
So when determining that, can you just look at the sample size and then go from there, or is there other factors?
There's other factors. Okay. Couple of things in this one. One, I do have a large sample because it's over 30.
Right.
But the primary reason I'm going to do Z is because I know the population standard deviation. So I really want to look first for the, which one do I have? Do I have the population standard deviation or do I have the sample? If I have the sample, that's when we're going to do T as in tiger. So this one, because it clearly says in that, fourth sentence, assume the population standard deviation of 14. I know the population standard deviation, I'm going to do Z. Now that I've decided which test to do, then I move to step 4, which is where we're going to go out and do our calculations. And we're going to use Minitab. Okay, and I'm going to try to write them up here first, and then we'll go out to Minitab and do them. Okay, this is going to look very similar to what we did last week. Okay, just hang on. We go to Stat at the top of the menu, at the top of the screen. We choose Basic Statistics, and then we choose one sample Z, which again, if you remember or think back, those are the exact keystrokes that we used before for the interval. Okay, we have to do a little bit extra with the command this time. Okay, again, we're using summarized data. So we use the drop-down box and change my option to summarized data because I don't have a list. All I have is my mean and all that stuff. We enter the info, and this time we're going to check the box next to perform hypothesis test, and we have to enter the hypothesis mean, which is the value we have in the hypothesis. Okay, so we have to check that extra box. Before, we didn't check the box for perform a hypothesis test. Okay, then we still have to go to options, and you're going to have to enter your confidence level. You got to be careful there, guys, because remember, the problem gave us the significance level, but Minitab wants the confidence level, and then you have to choose your alternative hypothesis. You have to choose whether you have less than, not equal, or greater than. You have to make that choice this time. Before, we left it as not equal. Okay, but this time we have to choose. Then we're going to click OK twice. All right, so I'm going to go out to Minitab, and I'm going to do this for you. Okay, so here we go. I'm out in Minitab. We go to the top of the screen to Stat, Basic Statistics, one sample Z. When the wizard comes up, we're using summarized data. It asks for the sample size, and from the problem, we know that the sample size was 37. The sample mean from the problem was 435. The known standard deviation, which is the population, standard deviation is 14. Click the box that says perform hypothesis test. My hypothesized mean was 438. That's what we had in the hypothesis. Options, we had a 5% significance level, so we have a 95% confidence, and my alternative hypothesis was less than. And I click OK, OK. What I need are these last two numbers here under the header test. You have a z-value and a p-value. The z-value is your test statistic. That's your evidence. The p-value is your probability value. Now, let me point out one thing. Notice here, when Minitab writes its hypothesis, it automatically puts an equal in the null. Some researchers do that. Some researchers will use equal in the null instead of thinking about less than or equal or greater than or equal. It's okay. We're doing it our way, but it doesn't affect the calculations, okay? So I'm going to record, I'm going to write down those two numbers. Okay, so I'm going to write down z equals negative 1.30 and p equals 0.096. Okay, so there is my test statistic and the corresponding p-value. I've written them down. Okay, then I'm down to step 5, where I'm going to, step 5, where I'm going to make a decision. Okay, I'm down to my deliberation. Are they guilty or not guilty? Okay, so to make that decision, remember we compare the p to the level of significance. So I have my p-value from Minitab is 0.096. My significance level from the problem is 0.05, and I'm going to add a 0 so that they both have 3 decimal places. Now, guys, for whatever reason, comparing those two decimals usually gives students the fits. I do not know why, okay, but it does. We compare it digit for digit. Okay, so if I look at the first digit after the decimal, in both values, it's 0. So there's no difference. But if I look at the second one, I have 9 compared to 5. 9 is greater than 5, so P is greater than alpha. And if P is greater than alpha, we fail to reject the null. Now, you got to stop and think what that means, because you got to write your conclusion. You got to come back to the judge and give him your report. Okay, think about it in terms of the court case. Remember, in terms of the court case, we have assumed the defendant is innocent until proven guilty. We've gotten down to the end and we failed to reject the null, which I told you meant they were not guilty. So if I fail to reject the null, does that make the null hypothesis true or false? It makes it true, okay? So if I fail to reject the null hypothesis, that means that my original null hypothesis is true. It was accurate. It's valid. So I have to write my conclusion in such a way to indicate that the null hypothesis is true. Now, there's lots of different ways to write it. I'm going to write it in the manner that you would likely see it written on a test or in your homework, because it usually goes back to the original problem. But the original problem here said that it was underfilling the bags, which means it's less than. But we've just proven that it's greater than or equal. So I'm going to add one little word. Okay, so here's step 6. Write conclusion. And guys, you should always include your level of significance. And so usually we start with that. We'll say at the 0.05 level of significance, and then I'm going to pretty much write that same sentence with one extra word. The bag filling machine is not underfilling the bags. Because we proved based on our data that the mean amount going into the bags was more than or greater than 438 grams. So they're not being underfilled. They're getting just enough or maybe a little bit more, which for the consumer is a good thing. Y'all with me? That usually kind of gets students right there making that sentence. But it's always written in terms of the null hypothesis. And we proved that it's not underfilling based on the data that we had. Okay, I want to skip down to question, let's see. To question 5. Okay, I want to skip down to question 5 on the last page. Again, we begin the whole process by reading the question. An article in the Atlanta Journal stated that students in the University of Georgia system take 4.5 years on average to finish their undergraduate degrees. Suppose you believe that the mean time for undergraduate degree completion is longer. You conduct a survey of 49 students and obtain a sample mean of 5.1 with a sample standard deviation of 1.2. Test your claim at the 0.01 significance level. Okay, so first step is to state the hypotheses. Again, you'll usually see it written with the null hypothesis on the top and the alternative on the bottom when they're stacked. Remember, you want to look for words like conclude, believe, think, determine. Okay? And this one's kind of in the middle because it says you believe the mean time for undergraduate degree completion is longer. And you may say, well, longer than what? Well, longer than what the newspaper reported as 4.5 years. Okay, so think about it for a minute. What math symbol would we use for longer? We would think about the math symbol greater than. If it's greater than, is that going to be the null or the alternative? That is the alternative. Very good, guys. Okay, so mean is greater than or longer than 4.5 years. If the alternative is longer, what's the null? Less than or equal to 4.5. Okay, then step 2, we identify the players. Again, for Z or T, you have to know the population mean, you have to know the sample mean, the sample size, you always have to know your significance level. And the one piece that can change that makes a difference for us is whether we have the sample standard deviation or the population standard deviation. So my population mean comes from the hypothesis, which would be 4.5. If I start reading, it says you conduct a survey of 49 students. So my sample size is 49. And obtain a sample mean of 5.1 with a sample standard deviation of 1.2. So in this case, I get the sample standard deviation of 1.2 and my claim, I'm going to test at 0.01. So my significance level is 0.01 or 1%. If my significance level is 1%, what's my confidence level? 99%, thank you. Step 3, we have to decide which test. Again, we decide which test we're going to do primarily based on whether we know the sample standard deviation or the population. In this case, Trey, this kind of goes back to the question you asked me a minute ago, because in this case, I actually do have a large sample, but I don't know the population standard deviation. So I'm going to do a t-test, okay, because I know the sample standard deviation, okay? So even though I have a large sample, I'm going to do a t-test because I only know the sample standard deviation. Now, the process then is we're going to do the calculation in Minitab. And the process is the same, okay, except you're going to choose one sample T instead of Z. It's the same process, but instead of one sample Z, you're going to do one sample T. Pretty much similar to what we did with our confidence intervals. So we go stat, basic statistics, one sample T. Again, we have summarized data. Our sample size, we checked with 49 students. Our sample mean was 5.1. Whoops, make sure you get in the box. 5.1. The standard deviation was 1.2. Again, check the box. We're going to perform a hypothesis test. My hypothesis mean from the hypothesis was 4.5. Options, my confidence level you told me was 99. And then I've got to change my alternative to greater than. And I tell it okay and okay. And again, on the screen, my values that I need appear. I get a t-value of 3.5 and a p-value of 0.001. Everybody good? All right, then we're going back. We're up to step 5. At step 5, we got to make our decision. We're going to compare P to alpha. P we got from Minitab, which is 0.001. Alpha is my significance level, which is 0.01. Again, compare it digit for digit. 0 compared to 0, there's no difference. Second 0 compared to 1. 0 is less than 1. So P is less than or equal to alpha. If P is less than or equal to alpha, we reject the null. If we reject the null, which we have initially assumed to be true, that means that my null is now false. Okay? So in this case, my null is false, which by default then means that my alternative is true. So again, there's a couple of ways you could write it. If you write it as straightforward as possible, you're probably not going to like it, because here's how it would read. At the 0.01 significance level, the mean time for undergraduate degree completion is longer than 4.5 years. Which looks like I simply wrote the statement that was in the problem that we said was the alternative. So you may think, well, I'm writing it in terms of the alternative. I could have said is the mean time is not longer than 4.5. That's kind of, you know, it gets kind of weird. So I really still have stated it in terms of the null hypothesis. Again, we just had to change the verbiage a little bit. Instead of saying is not longer, we left the word not out to put it in terms of the null. So sometimes that gets a little weird on how to word the conclusion. Main thing to remember is you have to state the level of significance, and you want to try to put it in terms of the null hypothesis, or so that it indicates that the null hypothesis is, in this case, false or true as appropriate. All right, questions? Okay, I hope you will spend some time between now and next week looking at the practice problems and the homework problems for both the Z and T interval as well as the Z and T hypothesis test. I'm going to put out the review sheet for the Module 3 exam, because we're going to be ready for that pretty much probably by next week. Okay, I want to give you an opportunity to ask questions. So hopefully you'll spend some time looking at the examples in D2L, and then come prepared to ask questions next Wednesday. All right, so I will see you guys next week.